with a transparent body and an eerie head shape. This is a peacock squid from the deep sea, with a demonic look and a large lantern atop its head. It is the anglerfish, capable of terrifying the faint-hearted. And there is this purple-red sea cucumber that seems to come from an alien world, swimming freely in the darkness. It looks very much like a fearsome creature from a sci-fi movie. As you might expect, the deep-sea world is lurking, with all kinds of strange and wonderful animals everywhere. They dominate their respective marine areas and together constitute a unique ecosystem in the deep sea. In the deep sea, at a depth of about 2,000 meters, there is a place that makes even scientists linger, which is the hydrothermal vent that continuously spews out billowing thick smoke. Conditions here are harsh and resources are scarce, but unexpectedly, life in these places is full of vibrant vitality. Whether it's the giant tube worms huddled closely together, constantly reaching out to explore, or the crustaceans crawling around them, with leisure and complacency, under the sunless deep sea, no matter how treacherous the environment, animals seem to find their own secrets for survival. Looking at these resilient fellows, one cannot help but ask, if it were the deepest and most terrifying zone in the ocean, is there likewise a group of little-known unknown creatures conducting a tenacious struggle against nature there? If so, what kind of untold secrets are hidden within them? In this episode, we will explore together the most mysterious place on Earth in the deepest part of the ocean, the Mariana Trench. The Earth we live on is a unique planet, composed of various tectonic plates. Due to the slow movement of the underwater crust, numerous deep fissures are created deep on the seabed, which are distributed across the ocean like trenches. To facilitate research, people refer to these miraculous fissures as trenches. Currently, there are about 30 trenches discovered in the world's oceans, of which the Pacific Ocean alone accounts for 14 of the 17 major ones. Located in the Western Pacific, east of the Philippines, there is a crescent-shaped trench about 2,550 kilometers long and about 69 kilometers wide. Because it is only 200 kilometers away from the Mariana Islands. On the west side, which are also crescent-shaped, people named it the Mariana Trench. The name Mariana originates from the 17th century Queen of Spain. Back then, she authorized Spaniards to establish missions on the archipelago, and later, the people on the island renamed the islands after the Queen to commemorate her. At the southern end of the narrow, slit-like valley at the bottom of the Mariana Trench, there is also a very famous spot named Challenger Deep. It is the deepest point in the ocean detected by humans early on, with a maximum depth of 10,948 meters. If compared with Mount Everest, the world's highest peak, Everest would be more than 2,000 meters shorter than it. For most of history, this was considered the ultimate dead zone, where no life on Earth could survive, because its seabed is not only completely lightless and permanently dark, but the temperature of the entire region is also only 1 to 4 degrees Celsius. Even more absurdly, the water pressure here is 1,100 times that of sea level, and it can easily crush any submersible that comes here. Despite the extreme conditions, it cannot block humanity's constant desire to explore. In 1875, an exploration ship from Britain, the HMS Challenger, first used weighted ropes during an ocean expedition to discover the Mariana Trench. At that time, the maximum depth recorded was 8,184 meters. The discovery of the Mariana Trench by the HMS Challenger unveiled the curtain for human exploration of the ocean's deepest parts. Subsequently, in 1889, a converted coal ship, the USS Nero, made new progress. The depth detected at that time was 9,636 meters, already close to the current deepest value of the trench. In 1951, led by British chief scientist Thomas Gaskell, the survey ship Challenger 2 began a new round of exploration of the Mariana Trench. This time, scientists no longer use traditional weighted ropes, but utilize more advanced echo-sounding technology instead. These new technologies were not only much more accurate than traditional ones, but also saved more time and effort. The depth detected this time was 10,900 meters, surpassing any previous record. To commemorate this great achievement, the expedition team named the deepest point of the trench Challenger Deep. 9 years after the discovery of Challenger Deep, in January 1960, a submersible designed in Switzerland, manufactured in Italy, and owned by the U.S. Navy, the Trieste, carried oceanographers Don Walsh and Jacques Piccard, taking 5 hours to sink to the bottom of the Mariana Trench at a depth of 10,916 meters. They were the first humans to come to this so-called land of death. This manned deep-sea vessel, which used iron pellets as ballast and gasoline for buoyancy, knocked open the door for humanity to enter the Mariana Trench. This historically significant submersible now rests quietly in the National Museum of the U.S. Navy in Washington. Doan and Picard later recalled that, at the deepest part of the ocean floor, they saw flatfish over 30 centimeters long and saw many huge amphipods. The seabed was clear and bright, covered with diatomaceous ooze. Following the Trieste, in the early 21st century, several others reached the abyss successively. For example, the famous director James Cameron, who directed Avatar, and Victor Vesavo, a private equity investor from the U.S. and retired naval officer. Victor is a fanatical enthusiast of deep-sea exploration. He dove into Challenger Deep 4 times, breaking the world record. As of 2022, a total of 22 manned dives and 7 unmanned dives have been achieved globally. Although the total number of dives is not many, each journey has given people a different understanding of the Mariana Trench, and those mysterious creatures hidden on the seabed began to be discovered one by one. In July 2011, a scientific research team first discovered in the Mariana Trench, within the Sirena Deep at a depth of about 10,641 meters, a creature named Xenophyophore. It is a giant amoeba. This fellow exceeds 10 centimeters in diameter. If you think discovering a bug over 10 centimeters long is nothing to be surprised about, you are wrong, because this is not a simple bug. In fact, it is a single-celled organism. That's right, it is just one cell. A cell over 10 centimeters in size. Scientists claim that the giant amoeba is the largest known single-celled organism on Earth, with the largest individuals reaching 20 centimeters in diameter. This fellow only lives in deep-sea environments. Previously, the deepest record for finding them was at a depth of 7,500 meters in the New Hebrides Trench. Finding them this time under 10,000 meters in the Mariana Trench also completely exceeded scientists' expectations. What makes giant amoebas impressive is not only that they are single-celled organisms, but more importantly, they play an extremely important role in the seabed ecosystem. Recent studies indicate that this organism can absorb elements such as lead, mercury, and uranium from the environment and accumulate them in large quantities. This suggests they may have a super strong adaptation to heavy metal environments. Lisa Levin, a professor and deep-sea biologist from the Scripps Institution of Oceanography, said in a statement, "As one of the very few biological groups found only in the deep sea, the giant amoeba is a unique symbol of the deep sea. They are fascinating giants, able to highly adapt to extreme conditions, yet at the same time very fragile. And currently, there is very little research on these organisms. It has been proven that in the trench once thought to be the ultimate dead zone, life does indeed exist. However, what many people care about is whether, under these extreme conditions, large fish, as described by Picard, would appear. To find more creatures in the abyss, in the early 21st century, Japanese scientists planned to sink a device equipped with a high-definition camera into the sea for long-term observation. To counter the intense water pressure, experts specially modified the design of the camera. At the same time, scientists also carefully prepared a large amount of sashimi and wrapped it around the lander device to attract any creatures that might appear in the deep sea. With everything ready, they lowered the lander into the ocean. After 3.5 hours of slowly descending, the device finally reached the deep sea bottom at 8,000 meters. Due to limited battery life, to extend the observation time, scientists set the camera to turn on once every 3 hours, with each activation lasting for 1 hour. Although they could not continuously observe the seabed's movements, the intermittent opening method of the camera brought a significant surprise to the scientists waiting in the observation room. In the first 3 hours, the device bait worked. It attracted a small shrimp-like fellow. Clearly, it liked the sashimi on the device very much. A few hours later, when the camera opened again, a large number of small peers had already gathered on the bait. They are a type of small amphipod. Scientists had long known there would be amphipods in these places, but their abundance was a bit unexpected. 8 hours passed, and besides these amphipods, no other fellows had appeared. Just when people thought there would be no more gains, a strange-looking fellow burst into the lens. Scientists in the observation room shouted with excitement because this was the first time humans had observed the existence of this species at a depth below 8,000 meters. This fellow, which looked like a tadpole, wiggled its tail and strolled leisurely near the bait. Although it strongly resembled a tadpole, quite clearly, it was a vertebrate fish. This species is called the Mariana snailfish. They are a deep-sea fish species in the family Liparidae. Scientific name, Pseudoliparis swire. Swire is the name of a crew member. He was the first navigating sub-lieutenant on the expedition ship HMS Challenger and also the author of the Challenger's Voyage Journals to commemorate the discovery of the Mariana Trench. By the expedition ship back then, people named this special fish after the lieutenant. Why would fish appear in such deep waters? To solve these mysteries, the research vessel Fokker used a deep water trap device in 2014 to capture the world's first Mariana snailfish from a depth of over 8,000 meters and conducted further research on it. The first thing to study was how they survive under high water pressure conditions. Scientists once conducted an experiment by sinking a large steel ball into the sea. When the massive steel ball descended to a depth of 2,000 meters, the thick steel ball was instantly torn apart because it could not withstand the enormous pressure. However, for marine life living under such conditions, most of their bodies are primarily composed of incompressible water. Therefore, when in an isobaric state, these animals will not be torn apart by water pressure. However, although deep-sea animals won't be crushed after reaching a certain depth, pressure will cause other different problems. For example, after descending below 6,000 meters, the pressure will destroy the cellular structure, since cells contain a large amount of protein, and protein is mainly used to perform the basic functions of life. When under high pressure, the pressure will force water molecules into the proteins. Once invaded by water molecules, the protein will immediately lose its effectiveness. The water pressure in the Hadal zone is immense. Destroying cellular structures here is as easy as turning over a hand. Later, through continuous research, scientists discovered that in many saltwater deep-sea fish, there is a special substance. It can actually hold on to water molecules tightly and prevent them from damaging the proteins. This substance is called trimethylam N-oxide, abbreviated as TMAO. Dr. Paul Yancey from Whitman College in Washington has long been dedicated to studying how deep-sea fish adapt to pressure. The doctor stated that TMAO levels in deep-sea fish are generally higher than those in shallow waters, and the deep-sea snailfish is currently the fish discovered with the highest TMAO content. As a piezoite in bony fish, Theory suggests it seems to allow these fish to survive to a depth of about 8,400 meters. While observing the Mariana snailfish, people found they weren't very interested in the bait. Instead, they seemed to prefer those shrimp-like fellows. It turns out these shrimp-like fellows are the primary food for snailfish in the deep sea. Snailfish may appear very fragile from the outside, but CT scans show that these guys actually possess powerful weapons on their bodies. We can see up to hundreds of teeth, densely distributed in their mouths. These teeth allow them to firmly grip their prey. Furthermore, there is a second, even more powerful set of tooth structures located in their throat area. It can be said that once prey is caught, there is no escape. But their prey, those shrimp-like fellows, are even more absurd. It turns out they are the ones with the most tenacious vitality in the Mariana Trench. Like the smaller ones mentioned before, they are also a type of amphipod, just with a much larger body size. These guys often haunt the 10,000-meter abyss. They are also one of the few animals currently discovered that can live at a depth of 10,000 meters. Compared to a depth of 8,000 meters, once 10,000 meters is reached, cellular proteins face new problems. Under stronger water pressure, proteins tend to stick together. Once proteins bond together, the animal's life activities will be terminated. Although TMAO can hold on to water molecules, IT cannot prevent the occurrence of protein adhesion. However, clever scientists always find the answer. A research team from Japan discovered another crucial substance in these animals, namely pseudoinositol. Pseudoinositol has a special molecular structure that allows it to insert itself between protein molecules. With the blocking effect of this substance, proteins behave and no longer try to bond together. Besides the protein problem, for these shelled creatures, water pressure brings another issue. Under the extreme pressure of the deep sea, the calcium carbonate forming the amphipod shells dissolves easily in water. Once they lose calcium carbonate, their soft bodies become extremely fragile. So, theoretically, amphipods should not appear below depths of 5,000 meters. But the reality is that at 10,000 meters, not only do shelled amphipods appear, but their shell hardness is also quite high. What kind of God-tier maneuver is this that allows them to once again defy nature? In 2019, a scientific team from Japan published relevant research results. They discovered that the shells of these amphipods have a gel-like aluminum hydroxide structure. This structure protects the calcium in the shell from high-pressure water. Aluminum is rarely found in seawater, but is abundant in sediment. When foraging, these guys can extract aluminum ions from the mud and use chemicals in their gut to convert them into the components they need. Amphipods themselves are the deep sea scavengers that feed on various debris. Some species can even secrete enzymes to digest wood and directly use wood falling from the surface as food. It can be said that they play a key role in the deep sea ecosystem. However, even if they eat decaying matter or wood, is there really enough food at such depths to sustain their survival? Life in the deep sea usually relies on organic matter falling from the surface. As these particles drift down, their nutrients are degraded by microbes attached to them. Therefore, it is estimated that of the organic matter produced in surface waters, only 1% to 2% can reach the deep sea below about 3,700 meters. How much can actually reach a seabed, like the Challenger Deep? It is still unknown. To learn more about life in deep-sea mud, scientists use submersible landers to obtain mud from the surface of the Challenger Deep. Researchers analyze oxygen consumption levels in the sediment. The results show that the oxygen consumption rate here is unexpectedly high. This indicates that deep-sea microbes at the bottom of the Mariana Trench are very active. Through comparison, scientists found the microbial activity here is even twice that of other microbial communities at a depth of 6,000 meters, 60 kilometers away. Scientists believe that because the Mariana Trench is so deep, it acts like a deep well, making it easier for various materials from the surface to settle and accumulate. The vast amount of sediment provides more material support for microbial reproduction. And these microbes might be the foundation of the deep-sea ecosystem, because there are indeed special microbes in the world with breathtakingly amazing abilities. Scientists once discovered a place resembling karst topography at a depth of about 5,700 meters in the Mariana Trench, filled with various miraculous landscapes. Here, a very mysterious animal often appears in the ROV's camera lens. Scientists call them deep-sea tube worms. In addition to tube worms, a large number of unknown white clams also appeared here. They form small communities, lying quietly in the cold deep sea. Scientists say the reason these animals appear in such a barren place is because the seabed here seeps out soluble chemicals that can provide for the animals' nutritional needs. In fact, earlier on, scientists had studied those living at depths of over 2,000 meters. Giant tube worms gathered near hydrothermal vents. The unique survival characteristics of these tube worms once overturned people's perceptions. Research found that when these guys are first born, they are no different from other animals. But as their bodies gradually grow, their digestive systems actually degrade and eventually disappear completely. This is very puzzling. Since their digestive system is gone, how do they digest food and obtain energy? It turns out that during their growth, a type of special bacteria slowly gathers in the middle part of their gut. Over time, these bacteria accumulate more and more, eventually forming a massive colony. By this point, the middle gut is expanded greatly, turning it into a structure called a trophosome. Thereafter, the nutrients and energy needed for the giant tube worm to maintain life are all provided by the bacteria within the trophosome. Simply put, bacteria have replaced the giant tube worm's digestive system. And these are no ordinary bacteria. What's special and powerful about them is that they can actually use chemosynthesis to oxidize the inorganic hydrogen sulfide from hydrothermal vents to obtain energy, and use this energy to process inorganic carbon and water together, converting them into usable organic nutrients. To better transport hydrogen sulfide to the bacteria in the trophosome, the tube worm evolved a special structure called a plume. These bright red plumes are filled with a large amount of hemoglobin, which can efficiently carry and transport hydrogen sulfide and oxygen. The tube worm provides hydrogen sulfide to the bacteria, and the bacteria provide nutrients to the tube worm. They share a symbiotic relationship. This is why they can survive in such desolate places. Currently discovered bacteria capable of chemosynthesis that can directly utilize inorganic matter, besides these sulfur bacteria, include nitrifying bacteria and iron bacteria. They can oxidize ammonia and ferrous compounds, respectively, to obtain energy from these inorganic substances. And the microbes beneath the Mariana Trench are so abundant that it truly cannot be ruled out that other special bacteria exist that can directly utilize inorganic matter on the seabed. Recently, remote submersibles have captured even more strange phenomena in the Mariana Trench via underwater cameras. For example, on the rock walls around the trench, deep-sea sea squirts were found. Also, a large number of deep-sea sea cucumbers were found in the footage. These sea cucumbers, like the famous sea pigs, have a ring of feeding tentacles to help them sift through mud and obtain food. Many scientists believe the large fish dome Walsh claimed to see in the Mariana Trench were actually sea cucumbers, because under such intense water pressure, the skeletons of vertebrates cannot withstand it. It's possible that because they were in the deep sea at the time, some visual distortion occurred and they mistook a sea cucumber for a flatfish. However, until recently, the now octogenarian Don still firmly believed in interviews that what he saw back then was indeed a large fish. Perhaps they really were mistaken, or perhaps humanity's discovery of the Mariana Trench is still insufficient. In short, the mysterious Mariana Trench still holds countless secrets waiting for humans to continue exploring.